Okay, today we're going to be working on our third tab of our Unit 14 foldable, which is Effects on Functions, and we're going to talk about vertical stretch. The past 2 days we talked about vertical shift, which means the graph moves up or down. Then we talked about horizontal shift, which means the graph moved left or right. And today we're going to talk about vertical stretch, and that's when the graph is kind of stretched up or down or scrunched up or down. All right, last week we went ahead and talked about what happens when you have numbers kind of at the end of a function, in the middle of a function. Today we're going to talk about when you have numbers in front of a function. So let's review a little bit. First day we looked over what happened when you had a number at the end. Okay, this created a vertical shift. Okay, so the graph moved up or down. And what we talked about is when it was positive, the graph moved up. When it was negative, okay, the whole graph shifted down. And the next day we talked about when you put a number here, okay, inside the parentheses, okay, when you got something happening with x, and that number there, what happens, it ends up shifting the graph left or right. So they call that, a horizontal shift. So they write horizontal shift. And if you add, the function actually moves to the left. When you subtract, it moves to the right. Okay. Today we're going to talk about when you have something that happens up front. Okay, when you have something that happens up front. And really what's happening, it's happening to everything. So I'm going to put a bracket around everything. Okay, so you have a number multiplied by everything. Okay, you have a number multiplied by everything that we're going to call A. Okay, what you end up having is you end up getting a vertical stretch. Okay, you get a vertical stretch when you multiply the whole equation by something. So that's going to stretch a graph up or down, okay, or it's going to scrunch it together. Okay, and we're going to see what happens when you put a number in front of the function with a few examples, and then we'll do a table. But the table should be fairly easy with this. All right, so let's go ahead and look at these two functions. So if you see the first function, f of x, you got x squared minus 1. So we know that should be a quadratic function, okay, which makes a parabola u. And so when we multiply a 2 in front of it, think what's happening. You're taking all of your y answers, and you're going to multiply them by 2. Okay, so the y answers are going to get bigger faster. So what that should do is that should kind of stretch it vertically. It'd be like putting your hand on top of the function and on the bottom and pulling. So if we look at the new picture, okay, notice how it looks like it got stretched. You pulled it up and down, so it got more narrow. Maybe you put your hands on the top and bottom, and you stretched it. So what they would say is this is vertically stretched by a factor of 2. Whatever you're multiplying by, that's what it's going to be vertically stretched by that factor. Okay. Our second example, we have an equation of a line, x plus 1. Okay, so we know that line looks like this. You have a y-intercept of 1 and a slope of 1. So again, when I put a 3 in front of it, it's going to be like pulling on the top and bottom, up and down, and just vertically stretching it. Okay, really pulling on it. So let's go ahead and see what that would look like. Okay, so it'd be like putting your hand on the top and bottom, and again, and vertically stretching it. In general, okay, this one's vertically stretched by a factor of 3, but in general, when you multiply by a number bigger than 1, okay, that's positive, like 2, 3, 4, 5, it's going to vertically stretch it. If you multiply by a fraction, okay, like 1/2 or 1/3 or 1/4, it's going to scrunch it because it's making all those y numbers smaller. So let's go ahead and look at a table, and we'll kind of look at a stretch and a scrunch, what it looks like with the table. All right, let's go ahead and fill in these tables, and I'll show you how it's easier to fill in the vertical stretch ones. Notice how the only difference between f of x and g of x is you're multiplying by a number, so this should create some type of vertical stretch. So let's go ahead through and fill these in. So when you put in 1 minus 3 is negative 2. The absolute value of that is positive 2. When you fill in 2 minus 3 is negative 1. The absolute value of that's positive 1. When you fill in 3, okay, you end up getting 0. The absolute value of that is 0. When you fill in 4 minus 3 is 1. The absolute value of that is 1. When you fill in 5 minus 3 is 2, and the absolute value of that is 2. So look at here. This is still the same. Okay, this is still the same in f of x. So the only thing that I did different is I put a 3 out in front. So it should make sense if you multiply all of these values right here by 3, that should give you the new answers. Because I had the same function right here, all I did was stick a 3 out in front. So I'm just going to simply multiply each of those by 3. So let's go ahead and fill that in. So 2 times 3 is 6. Okay, 3 times 1 is 3. 3 times 0 is 0. 1 times 3 is 3. And 2 times 3 is 6. Okay, so real easy. This last one right here, okay, from f of x to h of x. Okay, notice how this has f of x in it. So what I'm simply going to do if I want to rewrite the function, I have a half in front, and then f of x we already know is this function at the beginning. So really this is the same thing as 1/2 times the absolute value of x minus 3. So again, if I go back to the original problem, I can just take half of each of these y answers right here, okay, and go ahead and fill them in. So half of 2 is 1. Half of 1 from the first problem is 1/2. Half of 0 is 0. Half of 1 is 1/2. And half of 2 is 1. Okay, so these should be pretty easy. Again, you have a vertical stretch by a factor of whatever's multiplied out front. So if I'm multiplying by 3 out front, I'm just going to multiply all the y answers from the original one by 3. If I'm multiplying by a half out front, I'm just taking 1/2 and multiplying it by each of the y answers to get my new ones. Let's go ahead and look at a couple questions, okay, that I've written at the bottom that we've been doing. Okay, so let's scale down. Give you a second to go ahead and write these down. Actually, you don't have to write these down. Just look at them for a minute. Yeah, I told you didn't have to write them in your foldable. Okay, number 1 says, how can the graph of f of x be changed to get the graph of g of x? Okay, so if you look up, and again, all we're looking for is what's different. So in f of x and g of x, the only thing that's different is this 3. So since we multiplied by 3, you would say it has a vertical stretch of 3. That's how you get from f of x to g of x. So I'm going to go and write that down. Vertical stretch factor of 3. Okay, the second problem. How can we get to the graph from f of x to get changed to get the graph of h of x? Okay, so if you look at f of x to h of x, the only thing that changed is this 1/2. You multiply by a half, so kind of the same thing. So you have a vertical stretch by a factor of 1/2. So vertical stretch factor of 1/2. Okay, the third problem, you want to get from g of x to h of x. Let's go look at that. So you went from g of x to h of x. Now this part's the same, because remember, that's the same as the absolute value of x minus 3. So the only thing that changed, you went from 3 to 1/2. Okay, you went from 3 to 1/2. So technically you divided by 6, which is the same as multiplying by 1/6. Okay, so you actually multiplied 3 by 1/6 to get 1/2. So what you would say is you had a vertical stretch, the factor of 1/6. Okay, the last question. Suppose I wanted to create a new graph r of x in which I shifted f of x down 6 units, to the right 4 units, and vertically stretched f of x by a factor of 2. Alright, so let's go back up to f of x. And I'm going to rewrite the function down here. So f of x was originally the absolute value of x minus 3. Okay, so let me write that down here. So f of x was originally the absolute value of x minus 3. So r of x. Let's take care of the vertical and horizontal shift first. Okay? So originally, here's the original problem. So let's look at it. So to shift it to the right 4 units, remember, that's going to go inside of the parentheses or absolute value signs. If you want to shift to the right, you're going to subtract 4. Okay? And then it's vertically shifted down 6 units. So vertical shift is at the end. So down 6 at the end. So right now that's the same as x minus 7 minus 6. Okay, so that takes care of the horizontal and vertical shift. Now I want to do the vertical stretch. I'm going to multiply that whole thing by 2. So it's going to look like this. I'm going to multiply that whole thing that I just wrote down. Okay, which was that, by 2. And make sure you put parentheses around it because you are multiplying that whole thing by 2. So again, this part right here is the vertical shift and horizontal shift. So I just simply put parentheses around it and multiplied by 2.